Hello, it's dumplet here. Here's an item on algebra. R is a root to the following quartic equation: x to the fourth minus x cubed plus x squared minus x plus 1 is equal to 0. And we're asked to get the value of the expression highlighted in red. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, we've seen some of these questions before on the channel, and we do know that we're just going to do some algebraic manipulation based on the fact that, well, since r is a root to the quartic equation, we can substitute r in, and then it's going to become we're going to get that r to the fourth minus r cubed plus r squared minus r plus 1, that's going to be equal to 0, and find a way to manipulate the green term, the green expression, into something that we could use in the red term. Now, the problem is it's not actually that straightforward because, well, I mean, we could try to say, okay, sure, I could solve for r to the fourth from this equation. All right, r to the fourth is equal to r cubed minus r squared plus r minus 1, and probably substitute it in, but that's going to take a bit of a while, and because r to the fourth is not really a simple expression, so there might be something else here. And for a lot of people who do much of algebra, this should actually be a little bit familiar, or the x to the fourth minus x cubed plus x squared minus x plus 1. That should be a little bit familiar, because if I were to multiply x plus 1, right, to this one, I'm just going to multiply to the left side, because 0 times x plus 1 on the right hand side, well, that's just technically 0 anyway. So this is just simply x to the fifth plus 1. So it's it's just kind of the factoring tricks of x raised to an odd number plus 1 raised to the same odd number. So in fact, I would be able to get that x to the fifth plus 1 is equal to 0. So these are going to be, well, it's not really obvious, but for if you see the trick, then it's going to be pretty obvious. So probably the next time you're going to see a familiar setup, you guys will know what to do. All right, moving on. We know that, well, x to the fifth plus 1 equals 0. Obviously, you could put x as r, because r is still a root to the same equation. So r to the fifth plus 1 equals 0. And that's obviously going to have r to the fifth equals negative 1. All right. Now, r is not necessarily equal to negative 1 because, well, it should satisfy this one. But we do know that, okay, r to the fifth is negative 1. But not necessarily we're saying that r is equal to negative 1. Anyways, since we already have this result, we just put it in. So the r to the 20 minus r to the 15 plus r to the 10th power minus r to the fifth plus 1, that's just simply equal to, so r to the 20 is negative 1 raised to the fourth power, right? That's just simply because of the fact that r raised to 5 raised to 4, that's going to become r raised to 20. And we could do similar reasoning for the r raised to 15. It's going to be negative 1 cubed plus r raised to 10 is negative 1 squared minus r raised to the fifth is negative 1, and then a plus 1, that's going to be equal to 0. So the last step, just evaluate that. 1 plus 1 plus 1 plus 1 plus 1, and that's going to give us the answer of 5. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.